All right, I will give it just a second so we can get some people signed in here. All right, good afternoon, everyone, and thank you so much for joining us. Tonight we have Elin Betanzo, founder of Safe Water Engineering, here to share important information on lead in drinking water. Elin helped play a role in encouraging the studies that led to uncovering the Flint water crisis. So I'm so excited to have you here tonight. And tonight she's here to help educate us on how we can reduce the risk of lead exposure in our homes. And later this evening, we'll have Perry Hart, Battle Creek's utility administrator. He's going to join us to address what his staff is doing to protect our water and help answer any questions specific to our community. So thank you so much, Elin. And I'm going to go ahead and turn it over to you so you can do your PowerPoint now.
Great. Thank you, Chelsea. I will.
There we go. All right.
Okay, are we in business?
Yes. If you want to make it big.
Pardon me?
If you do like the slideshow presentation, it'll make it a little bigger.
I'm in the slideshow presentation.
Oh, okay. Then we will leave it like that. We can just see the extra slides. Okay.
You can see the other slides?
Yeah, we can see all the slides right now.
Oh, I see what's happening. Sorry.
That's okay. That's okay.
I'll get this eventually.
Technology's tricky.
Now I've got it. I've mastered it. I have to do it 3 times to get it practiced.
Perfect. Okay.
All right. Thank you, everybody, for coming tonight. I'm really happy to share with you this presentation that I like to call Everything You Need to Know About Lead in Drinking Water, but Didn't Know You Had to Ask. There's a lot going on with our drinking water, and sometimes we don't always get all the information that we need. So just to start off in framing this discussion, why do we care about lead? Well, lead is a potent irreversible neurotoxin. It especially affects young developing brains in our infants and young children. There have been lifelong multi-generational impacts that have been documented. And unlike some substances, lead has no useful purpose in the body. It does nothing positive for us. The health effects from lead are both acute and come from both acute and chronic exposures. We can have health effects from long-term, really low level, or very acute health effects, very immediate health effects from high doses of lead exposure. And what all of our health agencies, the Centers for Disease Control, the EPA, the World Health Organization, have all determined that no level of lead in the blood is safe. So where does lead come from? There's a variety of lead sources in our environment for a variety of reasons, and we've been phasing them out over time. So we have lead in our plumbing. We have lead paint. There's been lead gasoline in the past, and we've got a variety of different requirements that have been limiting those over time. Lead paint was banned in 1978. Lead and lead service lines was banned in 1986. We got a new drinking water regulation in 1991. But what we have from this legacy of lead in our gasoline and our paint and in our dust, sometimes in our food, is we have a very contaminated environment where there's a lot of lead exposure. But we haven't heard a lot until the Flint water crisis about the risk of lead in drinking water. So in comparison to some of these other lead risks, lead in drinking water is a lifelong exposure risk, because when we have lead in our plumbing, we have a risk of drinking it every single day. So when we talk about lead paint, frequently we're talking about toddlers who are crawling around, putting their hands on the ground and picking up dust and paint chips and putting it in their mouth. So there's a short-term, very important exposure window there for toddlers, But when we consider our entire lives, if we live in the same house with a lead service line, we do have a lifelong exposure risk. The population that's most vulnerable to exposure to lead in drinking water are infants, our bottle-fed infants, and pregnant mothers. If you consider an infant that is on formula, where every ounce of their nutrition comes mixed with tap water, if there is a risk of lead in that water, then that infant is consuming lead all the time in that water. So we really need to work on eliminating that risk there. But then, sometimes we have people who live in the same home their entire life and they continue to drink the water. So it's always there. We need to drink water to survive. So it's really important to know about the risk of lead in drinking water. So I want to talk about how we monitor our drinking water quality. Most of the time when we have contaminants in our drinking water, it's in the drinking water source, and we're able to measure for that contamination at a water treatment plant. So if there's microorganisms, or if it's contaminated with organics or inorganic contaminants or radionuclides, we can sample for that at the water treatment plant. We can remove it and make sure it's gone before we distribute that water to the public. However, lead in drinking water is different. After water is pumped out of the water treatment plant, we have some other contaminants that can be in the water. We have disinfection byproducts that can form as the water travels through the pipes. And we also sample for microorganisms because there is a risk of contamination within the water pipes. But the one set of contaminants that's very different is lead and copper, because the sources of lead and copper in water are actually in the plumbing, in service lines, and in customers' homes. So when we sample for lead and copper, it's not until the water gets into the customer home that we can sample for it. And our treatment for it is a little more limited because those materials are in the customer's home, and we're able to do treatment through corrosion control treatment at the water treatment plant. So let's talk about those sources of lead in drinking water. So usually in most cases, in all cases almost, when water is leaving the water treatment plant, when it's being pumped through our large diameter water mains, there is no lead in the water because there's no leaded materials that the water is in contact with. It's not till it gets to the small pipes, the small diameter service lines that connect the water mains in the street to an individual home, where we start getting that risk of lead in the water. So sometimes these pipes are made of lead, and sometimes they're made of a solid lead pipe that takes that water from the water main to the home. There can also be service lines made of galvanized steel, which also has lead content in it. The lead service lines are the largest source of lead in contact with water. It's the greatest risk of lead in water, but there's also sources of lead in customer homes. We have lead in fittings and fixtures. Up until 2014, we had this definition of lead-free plumbing that could have up to 8% lead by weight, and it could be called lead-free, but 8% lead content is actually really high. That was revised in 2014, and now the definition of lead-free plumbing has 0.25% lead in it. So there's a big reduction in the amount of plumbing in our lead-free plumbing, but that still means that there is lead in our lead-free plumbing. We also have a source of lead in our household plumbing in lead solder. And lead solder was banned along with lead service lines in 1986, but it is still available for sale. It can be used for non-drinking water applications, so sometimes it still ends up in customer homes in the drinking water plumbing, even though it is not supposed to be used. So these are all the ways when water is traveling from a water main into the home where water can pick up lead along the way on its way to a glass inside your home. So you might be thinking, why lead pipe? If lead is a potent irreversible neurotoxin, why would we be drinking water through lead straws? Well, there's a few different reasons for this. The lead material is soft, it's easy to work with, and in our Midwest winters here, it moves easily with the freeze and thaw cycles in the ground. It doesn't have as many breaks and leaks. It's really good to work with. plumbers have found it a very easy material to work with. And so back in the day, many communities actually required a lead pipe in order to connect to the water system. In fact, here is a charter, an ordinance from the city of Flint back from 1898 that said if you wanted water service in the city of Flint, it had to be made with a lead pipe. There was a lot of assistance here from the lead industry saying that lead was safe and a wonderful material. Another thing is that you cannot see, smell, or taste lead in drinking water. And so if there is a corrosion problem in the water, if there's a lead pipe, you won't be able to see it. If there's a corrosion problem in an iron pipe, you'll get red or brown water, and people will see that, they'll complain. So it's in many places, the lead pipe was preferred, even if they didn't know that lead was leaching into the water. The water systems over 100 years ago knew that they got fewer complaints with the lead pipes. But now we are starting to learn, or we know differently about the risk of lead in our water. So we have this rule, we have the federal rule, the lead and copper rule that controls levels of lead and copper in our drinking water. And lead and copper are grouped together in this rule because it is a corrosion control rule. It tells us we need to use corrosion control treatment to reduce the amount that these metals leach into water. And that's the only reason why these two contaminants are grouped together. They behave very differently. Actually, even their response to corrosion control treatment is very different, but they're grouped together because we address them through corrosion control. So corrosion control is typically an inhibitor, a corrosion inhibitor that's added at the water treatment plant. And as the water moves through the pipes, it coats the pipes with a protective coating that reduces the amount of lead that leaches into the water. So it's not foolproof. You can still get lead that dissolves into the water, but what that corrosion inhibitor does is it binds with the lead surface, the lead itself. It creates a mineral layer. It's almost like painting the inside of a pipe with a thin layer of lead paint, and it makes it harder for that lead to dissolve in the water. At the same time, that very thin layer of lead paint on the inside of the pipe, if that's shaken or disturbed, it can flake off in little pieces. Sometimes we call them lead particulate. And so that lead particulate, since it's bound with the lead itself, can have very high lead content. And so there is a definite risk if that lead particulate ends up in a glass, it could have very concerning levels of lead in it. And those particulates still can be so small that you can't see, smell, or taste them in the water. So it's important to note that corrosion control reduces but does not prevent exposure to lead in water. So lead levels in drinking water that we talk about with the lead and copper rule, and we have a new Michigan lead and copper rule that's more protective than that federal rule. We have two levels that we typically talk about in drinking water. 15 parts per billion is what we call the lead action level. This is not a health-based standard. It's a level that triggers additional actions in a water system. So if a water system measures lead over 15 parts per billion, then they have to start doing public education. They have to evaluate their corrosion control treatment. They have to start a lead service line replacement program or accelerate that lead service line replacement program. But what is so important to know is that 0 parts per billion is the safe level of lead in drinking water. This is what we call the maximum contaminant level goal. It's the level below which there's no known or expected risk to health. So that's where we want to be. Nobody should be drinking water at 15 parts per billion. So now that I've given a little overview about lead in water, I have a little bit of data to share for Battle Creek, and then Perry is going to provide a lot more content about what's happening in Battle Creek at the end here. But in Battle Creek, the water source is a groundwater source and uses orthophosphate for corrosion control. And so the lead levels that have been detected over the past few years under the Michigan lead and copper rule sampling, for 2020, the level was 2 parts per billion. That's what we call the 90th percentile for lead from all of the samples collected. The range of lead results were from 0 to 6 parts per billion. Back in 2019, the lead level for the entire city was 2 parts per billion as well. But in that year, the range of individual sample results went all the way up to 60 parts per billion. So there was at least one home there that had a lead sample above that 15 part per billion action level. And so what that means is the lead levels are consistently pretty low there in Battle Creek. So this is great. That means you've got good corrosion control going on. But it also means that every once in a while, there is a risk of higher lead exposure in an individual home. And so that's why it's important to know what your risk is at your own home. We have, for the first time ever in Michigan, we have new service line inventories. And so in the information that's Battle Creek submitted to the Michigan Department of Environment, Great Lakes, and Energy, there are approximately 5,000 lead service lines. That's a combination of known lead service lines and likely lead service lines. There's 250 unknown service lines where still doing some research to find out what those are made of. And that's out of a total of about 19,000 services in the community. So we've got about, 1/3 are possibly lead service, no, 1/4, I'm sorry. 1/4 are possibly lead service lines in the community there. So you might be wondering, what can I do in my own home? So one thing you can do is check for a lead service line. I'll walk you through that. Reduce your risk of exposure to lead in drinking water. I've got several steps to do this. You can ask your water utility and local decision makers about the lead in the water and what their plans are. You can participate in water sampling programs, and you can share the information that you learned tonight with your community and your neighbors. So I'm going to kind of talk through some of the benefits we have now with our Michigan lead and copper rule. It was finalized in 2018 in response to the Flint water crisis, and we have the most protective lead and copper rule in the entire country right now in the state of Michigan. And so one of the important provisions in this rule is that all water systems in Michigan must have a verified service line inventory by January of 2025. They've already submitted preliminary inventories that were due last year. And prior to this, there was never any requirement for water systems in Michigan to know where lead service lines are. So this is a really big protection for people. Once the water system knows where the lead service lines are, they are required to notify you if you have a lead service line at your home. Both the resident and the owner must be notified in writing if they have a lead service line and anytime they open a new water account. So if you have received a letter that you have a lead service line, you're good to go. You know you have a lead service line. If you haven't received a letter yet and you're concerned, one thing you can do is check in your basement. So these are the steps for finding out if you have a lead service line. So if you go into your basement or your crawl space, you want to check a small section of pipe that is between the floor and your first shut-off valve, or sometimes it's between the wall and the first shut-off valve. So you can see there's a lot of piping around here. It's only this little bit that's in the box that's the part that actually matters, because this is the only part of that pipe that you see that might be the same material as underground and to the water main that serves your house. So you want to look at this section of pipe and see if it meets some of these test criteria that I'll show. Now, it's important to note that what you see in the basement could be different than what's underground, because different repairs over time, different codes over time may have resulted in changes in the yard or a change inside that wasn't made in the yard. So for example, here is a picture of an excavated service line where at one point a copper service line was installed, but here there's a little tail piece of lead that you can see here. So this service line is actually a lead service line, but it's possible that you might, in this particular home, may have only seen copper inside of the house. So the take-home message here is if you see lead inside your house, that means you do have a lead service line. If you don't see a lead service line inside your house and you live in an older home, you may still have a chance of a buried lead service line, and that's when it's really important to coordinate with your water utility. So these are the typical materials that you might find when you check that section of pipe in your basement. A copper service line looks like the color of a penny. If you try to scratch it, you'll see that shiny copper color. It is not magnetic. So if you bring out a magnet, it will not stick to that copper. If you have a galvanized service line, if you try to scratch it, it will not scratch very easily. It is magnetic. So if you have a magnet, it will stick, it will cling to that piece of pipe. A lead service line, if you scratch it, it is very soft. Be careful when you scratch your lead service line. You will see some shiny metal underneath there. And that's because it is a softer material. That lead is not magnetic. So even though both the galvanized and the lead are similar in color, the magnet will cling to the galvanized. The magnet will not cling to the lead service line. We also sometimes encounter plastic service lines in the world. And so that has that plasticky color. It's not a metallic look. It is not magnetic. So these are the types of materials that you could find when you go investigate in your basement. So here are...
Oh, so sorry to interrupt. We had a question, and I think it pertained to one of your previous slides, so I did just want to throw it in there.
Okay.
Someone asked if we can clean our waste pipes or lines by using special additives with weekly waste, like running bleach 2 quarts per drains.
So I'm talking about the drinking water side today. Maybe that's Perry might want to comment on that later. But yeah.
Thank you.
So let's see, talking about service line materials. Here are a variety of pictures of lead pipes. So if you have a lead pipe, what it might end up looking like in your basement. Another characteristic of a lead pipe is the white joint where it connects to the valve or the meter. And that in some of these pictures, you can see where it looks like perhaps a snake that swallowed an egg. You see a bulge right where it is meeting the joint. So this one has a little bulge, this one has a bulge. And so if you see that bulge on your service line pipe, then you know right away that it's definitely a lead pipe. There are other different types of connector pieces that don't always have that bulge, but that snake that swallowed an egg look is one that really gives away the lead pipes. You also see that all these lead pipes are very curvy. The other pipe materials are not going to bend and curve. They're going to more likely have 90-degree angles or very straight pipes in your basement. Here are some examples of copper service lines. Sometimes you see a little bit of that blue-green tarnish when that copper starts to oxidize. So that's another giveaway on your copper pipes. Sometimes I have seen people paint service lines or wrap them. That means you're going to have to chip off a little bit of paint or unwrap the service line to be able to see what that material looks like underneath. So those are examples of copper lines. Sometimes we just can't tell inside the house. Sometimes that valve is right at the floor level and you're not seeing any section of that pipe that is actually underground. So we can't tell. That's when you really need to call the water utility and say, what do you know about my service line? And so some of these other pictures, sometimes people send me pictures of their service lines, but since I don't have a very good close-up, I can't really tell what materials some of these are. So there are a few occasions where it's hard to tell what that service line is made of. Now, some really important new protections we have in the state of Michigan is we have a ban on partial lead service line replacements. And let me tell you what a partial lead service line replacement is. A service line typically always goes from the water main to the house. But in many communities, we've kind of divided up the ownership or responsibilities about that service line at the property line. So sometimes we talk about a city responsibility service line and sometimes a property owner's responsibility. So in the past, it had been very common if a water utility was replacing a water main, they would only replace the portion of lead service line that was on the city side, and everything that was on the household side, they wouldn't touch, or they might offer to replace it, but they wouldn't guarantee replacement. So this is what we call a partial lead service line replacement. And they've been very common. So right now, there might be many situations where there is a non-lead service line on the city side or the water main side, and there might still be a lead service line in place on the private side. But partial lead service line replacements can greatly increase the risk of lead in drinking water. Cutting that lead pipe can release actual lead particles into the water. That construction and excavation can shake the lead pipe and loosen the corrosion control coating on that pipe that I talked about earlier, and that releases particles of lead into the water. And then if you connect a lead service line to a copper service line, then the two dissimilar metals create a galvanic corrosion connection and can actually increase the rate of lead leaching into the water in the home. So for this reason, the practice of partial lead service line replacement is no longer allowed in Michigan. They're only allowed in cases of emergency where there's like an overnight leak that needs to be addressed. You can do a partial, but you're supposed to follow up with a full lead service line replacement shortly thereafter. So this new requirement, this ban, is a huge protection to the residents of Michigan. We are also the only state in the country right now to require all lead service lines to be removed within the next 20 years. This year, 2021, is the first year that this requirement comes into play. Water systems are supposed to replace an average of 5% of their lead service lines per year. And this is because the only way to to prevent exposure to lead in drinking water is so to have your water not in contact with lead at all. So removing those lead service lines is the permanent solution to that high risk exposure to lead from a lead service line. And the best time to remove a lead line is before it becomes a problem. We don't want to wait till that becomes a documented problem. We want to get it out before, because lead is a potent, irreversible neurotoxin. So this is a great thing we have in Michigan, and the entire lead service line needs to be replaced at the water utility expense. So if you have a lead pipe and the water utility is working on that 5% annual replacement goal, they won't send you a bill for replacing that lead service line on private property, though that cost needs to be addressed at the water utility level. We also have some new requirements for sampling for lead in water. Under the old lead and copper rule we had in Michigan, water systems were required to sample the first liter of water out of the tap after about 6 hours of no water use in the home. So when you collected that first draw of water, it would measure lead contributed by household sources of lead, the faucet, the lead solder that are in place. But that first liter of water very rarely contains any water that's been sitting in a lead service line for a prolonged period of time. So if you lined up your 1 liter sample bottles on the counter and started filling them up, it would probably be around the 5th or 6th liter of water that you would really be capturing water from the lead service line. So this is lead data that we'd never gotten before, but now that we have the Michigan lead and copper rule, in 2019 was the first time we started doing new sampling. Water systems that have lead service lines now have to capture both the 1st and the 5th liter of water out of the tap. And that 5th liter is more likely to represent water that's been sitting in the lead service line. And so as a result, we have a better representation of the lead that is coming from lead service lines in homes that get their water from a lead service line. And so, as I had mentioned previously, that there is additional sources of lead inside the home. That lead service line is the largest risk of lead exposure, but it's really important to be aware of the other sources of lead in our plumbing. As I mentioned, lead solder that was installed prior to 1986 and improperly installed after 1986 can create some high lead content in household plumbing. Materials that were not intended for drinking water use have no requirements for lead whatsoever. So there can be any lead content. This can include garden hoses, spigots, laundry faucets, shower heads, some hand washing faucets, If it was not intended for drinking water use, nobody is looking at the lead content of those materials. Really important to be aware of this. Materials that were marked lead-free that were sold through the end of 2013 could have up to 8% lead by weight. And then that definition really reduced in January of 2014, where now lead-free plumbing must have 0.25% lead by weight. So these are all things you might find in your home, even pretty recently built homes up until 2014. So, healthy water tips to reduce your risk of exposure to lead and water in your home. First, use a filter that meets NSF standard 53 for lead reduction. I'm going to walk you through a few labels there to help you find that. If there's a pregnant woman or children under age 6 in the home, consider a filter even if you don't have a lead service line. Always use filtered or bottled water for baby formula. There's no reason to take risks with baby formula. Always use cold water for drinking or cooking. Warm water can dissolve more lead, so cold water is the safer way to go. And if you, run the water until it's cold and then run 2 more minutes before drinking or cooking, this is flushing the water to reduce the risk of lead. This is to get fresh water from the water main. And when you're doing this, you can use that water. You don't have to send it all down the drain. You can flush the toilet, clean the dishes, water plants with that water. But flushing is a little bit less reliable for lead control than using filters. Also important is removing and cleaning your aerators on a regular basis. And the aerator is a screen at the end of the faucet that can capture lead particles. And I think I have another slide that goes into detail on that one. So using a filter and looking at filter labels, the industry has made it a little bit tricky for us to identify filters that are certified for lead reduction. So we want to look for products that are certified to NSF 53 and 42. 53 is the important one for lead, and it has to mention NSF 53, and it has to mention that lead is one of the contaminants that it's certified to reduce. Standard 42 regulates particulates. And so when it's certified for both 42 and 53, it's reducing particulates and lead. So that's what you want to look for. Here is a box for one product. It mentions that it meets both standards 42 and 53, and it's certified for lead. Here's another product box that also mentions that it is certified to 42 and 53. But when you look at their list of contaminants that it reduces, lead is not on the list. So this product is not the product that you're looking for. So reading the labels on the filters is really important to be careful. Another thing you might see occasionally on a filter package is that the filter has been tested and certified to NSF standard 372 for lead-free compliance. What that's actually telling you is that that filter is not going to add any new lead to your water. So that's not the certification that you're looking for as well. So be on the lookout for that one. It's not what you're looking for. But the good news is that you can find these certified filters in all different types of filters. And what we like to use point of use filters, where the water passes through that filter is the last thing it does before it enters your glass. And that's because there are sources of lead throughout the home. Sometimes there are point of entry filters, but those are not the best for lead control because there are lead sources in your home. But you can find pitcher style filters, you can find faucet mount filters, there are refrigerator or countertop models, and they're really great. I use a refrigerator filter for all of my drinking and cooking water in my home, and I just check to make sure every time I change my filter cartridge that I'm getting one that is certified to NSF 53 for lead reduction. So you always, no matter which one you're getting, no matter which style fits your lifestyle best, check for those certifications and always replace the cartridges according to the manufacturer's instructions. This is the slide on the aerator cleaning. So the aerator is like a screen at the end of the faucet and it can capture lead. So it's really important to clean that out on a regular basis. And after any work, any plumbing work or construction work around the home where it could shake up the pipes, sediment can collect in there. I recently did a little bit of bathroom work in my house, and I took out the aerator, and it was full of all sorts of sediment. So getting in the habit of cleaning that out on a regular basis is important. So if it's been a while, it might take a little effort to unscrew that aerator off of the faucet to clean it out. Brush it with an old toothbrush. After you've used that old toothbrush, never use it for your teeth again, but you can use it the next time you clean your faucet aerator. Especially if you've had any work being done on your plumbing or near your house, any construction work, you want to flush the pipes before you start drinking the water again. And so there are steps here to walk through there. Remove the faucet aerators from the faucets, begin at the lowest level and open the cold water taps, walking from the lowest level to the highest level. Let the water run for 5 to 10 minutes, and then you go back to where you started, starting back in the basement. Turn off the pipe, turn off the faucet, and then work your way back up to the farthest faucet on the top floor. And then you can brush off those aerators and reinstall them. That's a great practice, especially if you've been doing plumbing work in your house, or if there's water main construction in the street, just to clear that all out from your house. So just to summarize what I have here, I like to pay a little more attention to my lead reduction habits if I'm in a home with a lead service line. So always use a filter that meets NSF 53 for lead removal for all drinking and cooking water in the house. Always use filtered or bottled water for baby formula. Always use cold water for drinking and cooking. Clean the aerators regularly, and flush that household plumbing after construction or other disturbance in the home. If you don't have a lead service line, you can kind of take a step back with your vigilance, but still be aware that if there's a pregnant woman or children under age 6 in the home, consider using a certified filter. Always use a filtered or bottled water for baby formula. Still, always use cold water for drinking or cooking. And then if you don't have a lead service line, that's a situation where I'm more comfortable with using flushing for lead control. So in this case, run the water until it's cold before drinking or cooking. You can use that water for something useful, like flushing the toilet, cleaning the dishes, but also remove and clean the aerators regularly. So I have a copper service line at my home. I remove and clean my aerators regularly, and I run the water before I drink the water, especially if I'm upstairs in the bathroom brushing my teeth. I want to just do a quick little mention of lead in school drinking water because sometimes we've been hearing in the news about lead in school water. We have no federal or state drinking water requirements for schools that get their water from a community water system. There are some schools that have their own wells. They do have some of their own requirements. But in our schools, we have the same type of leaded plumbing in the schools as we do in our private homes. Now in schools, we have irregular water use patterns. Generally at home, we're using the water almost every single day. But in schools, we can have weekends off, we can have week-long breaks, summer-long breaks, COVID-long breaks. And so these irregular water use patterns means that the corrosion control treatment doesn't get to work the way it was intended to work. So what we end up finding a lot is when we sample for lead in schools, we tend to find it. And so instead of chasing that lead around and trying to find where it is and trying to take temporary steps to reduce that lead, I'm a fan of using filters to ensure that there is a reliable source of safe water in schools. Installing a filter stations focuses on providing safe water first, and then sample those to ensure that they're working as intended and as certified, so that there is a reliable source of lead in schools. Anytime a filter station is installed in school, it should be part of a drinking water safety plan. There should be a plan for changing out those filter cartridges, a plan for sampling to make sure it's working, a plan for flushing the school water, especially at the beginning of every school year if it's been stagnant over the summer. It needs to be part of a comprehensive program, but they can be very effective for providing safe water in schools. So I do have some links for some resources, and if there's the ability to share these after the presentation, I'd be happy to share the hyperlinks here so you can follow up if you're looking for more information. But that is the end of my prepared part of this presentation, so I will stop sharing and hand it back over.
My mic was muted. Sorry. Thank you so much for that wonderful presentation. And now I would like to go ahead and introduce Perry Hart, who is Battle Creek's utility administrator. He's been a certified water operator since 1987 and has been in the water profession since 1985. He has 36 years of experience in providing safe drinking water to the public. So thank you so much, Perry, for agreeing to join us tonight and talk about what's happening in our community to protect our water.
Thank you, Chelsea. Elin, very good presentation. You shared greatly what folks can do in their homes to safeguard themselves about lead. I'd like to share a little bit about what the city of Battle Creek has done. As Chelsea said, I've actually been in the water industry longer than the lead and copper rule has been. There's not very many of us left in the industry at that rate. So I came to the city of Battle Creek in 2008, and I can share a little bit of history. Prior to, or at the beginning of the lead and copper rule, the city of Battle Creek was doing their corrosion control treatment at the wellheads themselves. They were treating with the phosphate product right where the water came out of the wells. They had reached the appropriate balance of dosing so that they were on a reduced monitoring plan with the state health agency, which has changed over the years. It's now EGLE, Environmental Great Lakes and Energy. In 1998, the city of Battle Creek invested in a water treatment facility that removes radon, iron, and manganese. Part of that treatment process is aeration, which creates increased dissolved oxygens in water. That in turn turns water into a little bit more corrosive substance, so it was going to attack our lead service lines. Steps were taken to go through the entire process of determining the appropriate polyorthophosphate treatment. Worked with a number of different vendors, settled on one after several years of testing and actually doing coupon testing where coupons of the water main material and lead service lines were exposed to the drinking water in a controlled manner so that the effect of the water on the piping could be evaluated. All those things proved to be beneficial in determining what product to use and at what rate it needs to be dosed at. We now do that dosing right inside the water treatment plant instead of at the wells. A little bit more history. After we went through that process, we were once again in the reduced monitoring period for the state until 2014, 15. After hearing all the news about Flint, I went digging in our file cabinets and found that perhaps our sampling pool wasn't quite accurate. I brought this to the attention of the EGLE, and we sat down and realized that due to the change in the definition of what a lead service line actually was, we were no longer compliant with the sites that we were sampling. So we took immediate action to identify Tier 1 sample sites to get back in compliance with the regulations of the Safe Drinking Water Act. In doing so, we continue to monitor those. Over the last 3 years, we had to go through the entire qualification process for determining what sampling frequency. Then in June of 18, with the passage of the new lead and copper rules with the state of Michigan, where Elin referred to them becoming more strict than any other state, we now are on an annual sampling. And previously, we did the sampling for not only our water community, but we have downstream retail customers in Emmett Township water system, City of Springfield's water system. We have one in Leroy Township. These communities now have to do their own lead and copper testing under the new regulation. So things have changed a little bit over the last 3 years. We continue to work with these downstream cities and assist them in getting into compliance, and they've both done a super job. There's been some hiccups in the reporting of it, as can be expected when a new task is thrown upon you, but the results have been good all along because of the corrosion control treatment we have at the City of Battle Creek. As Elin pointed out, if 15 is the you got to do something more about this, and we're down at 1 and 2, we're doing a pretty good job of getting the corrosion control equally distributed throughout our system. Elin, you did point out that we had a real high reading result near 60 during one of our sampling cycles. We did do further investigation on that with the residents in that home, and it was determined that the very high rate range on that sample itself was not likely caused by a lead service line or a disturbance in the water system, but more so we found out after the sample taking that there was plumbing work being done in the home that we weren't aware of prior to that. With that, we have started, we no longer have for years, sampling was done by the customer. We would leave the appropriate bottle on the customer's step. They would let their plumbing go stagnant for 6 hours. We'd ask them to sample in the morning and make sure nobody had used water, answer a survey question regarding water softeners or filter systems. We have taken it a little bit more seriously moving forward, and we now make appointments and send water department staff in to collect the samples now that we do the 1st and 5th samples. Elin explained that is getting an idea of what the lead content is on the water that's within the plumbing in your home, and also a measurement of the lead that's in the service line leading to your home. So moving forward, we have last October, we did get a letter sent out to all of our residents with known lead service lines or the unknown lead service lines. We did the best we could with the data we have and got a letter out to them saying that they may be drinking water out of a lead service line. We wanted to make sure they were aware of it. That way they have the opportunity to go out and take the precautionary measures that were shared here. Additionally, we have worked with our utility billing department where if one of these homes or buildings with potentially lead service line involves rental units, those rental units tend to change occupants frequently. We've made the steps necessary where our utility billing clerks have a handout that they can give to anybody moving into those addresses. That gives them the awareness that there are precautions they should consider, including the filtering. Got that taken care of last fall. We have continued to work on what we refer to as the vac and verify process. We purchased a very large piece of equipment that is able to vacuum down through front yards and take a look at the service line material serving different homes. Since the June of 18 passage, we knew we were going to be able to do this. So we were kind of being proactive in getting ahead of the game. We have just recently received news from Eagle about a defined process that's going to help us determine the distribution material inventory. We've got to have this completed by January 1 of 25, in which we're using a logarithm and statistics to determine where our service lines are, what materials they are made of, and which ones need to be replaced within the next 20 years. To date, we have been replacing lead service lines in the right-of-way where they are connected to copper on our water main replacement. But where they are connected to galvanized, we are replacing the entire service line into the home. Our first priority is in the roads that are being, roads that are being reconstructed or resurfaced. We're trying to get in there and put our holes in the ground before the streets get rebuilt over the top of them. Secondly, we are concentrating on areas of town that we have a known high concentration of lead service lines. We've got several of those planned for later this year ahead of 2022 street reconstructions. And then beyond that, we are going about identifying where our lead service lines are. In checking the records earlier today, I was able to determine that the last lead service line that was installed in the city of Battle Creek was in 1968. So we're way better off than the folks that had them installed until 1986. We do have approximately 4,300 of them left to take care of in the next 20 years. I also was able to dig up some rules and regulations. Unfortunately, the rules and regulations book that we have doesn't have a date to it. But It appears to coincide with that 1968 date, because the rules and regulations state there that any water service line going into the water meter inside a home would be of 1 inch or of copper, not less than 3/4 inch. When you're dealing with residential service lines going in homes made out of lead, you're generally dealing with plumbing that is 5/8 inch in diameter, internal diameter. So there's some confidence in those documents, but it's not going to be accurate enough for regulatory requirements coming up through the 2025 deadline for distribution system material inventory. I guess that kind of gives you the rundown of where we're at with lead service lines. 4,300 left to go. Hopefully the numbers that Elin shared with you earlier from our consumers confidence report, we hope those numbers change dramatically over the next several years and we start seeing some progress. We're still finding challenges in doing the work itself. We've done some with contractors, some with internal staff. We're trying to find the right balance, the most efficient way to get the lead service line, because replacing them is a cost for every water user of our system. We have to be wise with the money we have to use and go about getting these service lines replaced as efficiently as we can.
Thank you so much,
Chelsea, did you want me to address the one question that came in there?
Yes, if you have an answer, that would be great.
If he would care to contact me outside of this through my email address, if you could provide that to him, I'd be happy to get him connected with our sewer division staff that could help on that line. Yep. But there are several products out there that can be used to treat your sanitary sewer lead going back out to our public sewer system. I am not one to promote name brands. I'm very cautious about that, but there are products that can, they remove one of the largest problems you have with the sewer lateral going out to the public system is tree roots getting in through cracks or joints in the pipe, and they can lead to blockage. There are some products out there that can be used. Whenever I get a chance to talk sewer pipes, I always want to share with folks, avoid using the wipes. The wipes and the pipes are a headache like you would not believe.
Yeah.
And I think that's about all I have for you.
Thank you so much. It has been, I'm so glad we could get both of you here today. I think it's been very informative, and it was great to know a little bit about what our community is doing. It does look like we have a few questions already, and anyone else that has any questions, please feel free to ask. Definitely use them to our advantage to answer any questions you might have. So the first one that we have, can reverse osmosis water machines. Some cities are using Teflon iron skin tubing. Can they help keep the lead out? I don't know anything about this stuff, so I'm just reading what I have and hoping you guys can translate for me.
There are reverse osmosis treatment units that can be used to reduce lead in water. They're certified to NSF standard 58. So you'd want to be looking for those if you want to take the reverse osmosis path with your water. But same idea, you want to go with point of use treatment in your home rather than point of entry with that reverse osmosis. And then the reference to, I think, you're talking about lining techniques to reduce lead. The Michigan Lead and Copper Rule does not allow lining techniques as an alternative to replacing lead service lines. Perry, did you have anything you wanted to add?
I do. Reverse osmosis is a very finite treatment process. You get very good water quality out of such a device, but they do require maintenance and they do need to be installed correctly. A reverse osmosis filter not maintained is not going to do you much good at all. And having been in an inspection role as part of my 36 years in the water industry, I've come across several reverse osmosis installations where it was actually connecting the drinking water to the sewer line directly. So if you're going to take advantage of reverse osmosis, please get the appropriate device or hire the appropriate people to install this device. There's another hazard out there unrelated to lead called cross-connection control. And reverse osmosis machines or filtration systems tend to violate that requirement. So please be careful, ask the right questions, get the right people involved if you're going to install that type of filtration system.
So, kind of continuing on that, and you gave us a lot of good information. So, if you don't have anything to add, but they said, what can those filters do for my house cooking and drinking?
Elin shared that. It's best using it as a point of use filter rather than trying to filter your house. Reverse osmosis maintenance and sometimes electrical power are expensive uses. If you're using that for your shower or your bath water, it's really a waste of the asset. It's best to use them just for the water that you're using for cooking. Reverse osmosis is fantastic at removing the particulate Elin referenced because it's using a finer filter than any of the other, like the filter in your fridge is a basic charcoal filter. The reverse osmosis has a much higher degree of removal than those typical pitcher filters.
Fantastic. And the person said, thank you very much. And that, yes, it was for 58 standard. And that was just what you wanted to hear. So thank you. And I think that is all of the questions that we have. So thank you both so much for being here. And yeah, I just appreciate both of you taking time out of your busy schedules. And I know that I learned a lot. I don't have city water. I have well water. So that's something I'll have to look into kind of on my own. And be a little more cautious about. And you guys were just on my street replacing lines because we just got a new road. So that was interesting to hear what was going on. So yeah, I just thank you both very much, and I hope to work with you again in the future.
Thank you.
Thank you, Chelsea. Elin.
Thank you.